Hi, and welcome to Neurabytes. My name is Navjinder Virdee, and from this lesson, we will start implementing the basic operations of the linked list. We will start with the insertion operations first. We will learn about two insertion operations. Number one is PushFront. It adds a node at the front of the list. And number two is Pushback. It adds a node at the end of the list. Let's start with PushFront. Let's suppose we are given the following list and we want to add node 30 to it. Then after adding the node 30, the updated list would look like the following. Node 30 becomes the first node of the list and the head now points to node 30. Now let's learn how PushFront works. The first step is to assign the head reference to the next pointer of the new node, which can be done by new node.next is equal to head. Let's say we are given the following list and we want to insert node 30. After performing the first step, both the head node and the new node's next pointer are referring to the node 10. Now, the second step is to change the head reference to point to the new node instead of the node 10, which can be done by head is equal to new node. Now head points to node 30 and 30 points to node 10. That's it, we have inserted the node 30 at the front of the list. Let's code the function now. In the previous lesson, we implemented the node class and the head node. If you haven't seen the last lesson, then please check it out. I have provided the link in the description below. So, first we need to create a new node with the given data. Then, if the list is initially empty, then we will just point the head node to the new node. Otherwise, if the list is not empty, then we will perform the following steps. First, we will point the node.next to the head and then the head to the new node. And finally, we will return the head. Now, let's add some nodes. Traverse is a function that I have coded and we will learn about it in the next lessons. Currently, it will print the whole list. So, we will insert 3 nodes 30, 20 and 10 and let's see how the list looks like. So, as you can see, initially we inserted node 30, then 20 becomes the first node, and finally the node 10 becomes the first node. Let us learn about pushback now. Let's say we are given the following list and we want to insert node 30 to it. Then the updated list would look like the following. Node 30 is at the end of the list. So let's learn how pushback works. The first step is to create a temporary node and assign head to it. Now, both the temporary node and the head are referring to the node 10. The next step is to traverse the whole list and get to the last node using the temporary node. Initially, temp is pointing to node 10, then to the second node and finally to the last node. After reaching the last node, the temp node is pointing to the node 15. Then, the next step is to assign the temp node's next pointer to the new node. That is node 30. That's it. Now, let us code the pushback function. First, we need to create a new node with the given data. Then, if the list is again empty, then we will just point the head node to the new node and return the head. Otherwise, we will create a temp node and assign head to it. Then we need to traverse the whole list and get to the last node. After reaching the last node, we will assign temp node's next pointer to the new node. And finally, we will return the head. So let's add some new nodes at the end of the list. Again, traverse is a function that I have coded. It will just print the list. We will learn about it in the next lesson. Let's see how the list looks like. So initially we had 10, 20 and 30 using PushFront. Now we have inserted the node 40 at the end, and then the node 50 is at the end, and finally the node 60 is at the end of the list. So we have inserted 3 nodes using PushFront and 3 nodes using Pushback. It is very important that we also know the time complexities involved in these operations. So the first function, the time complexity of the PushFront is constant time, because we only changed the head reference and the new node's next pointer, and these are constant time operations. Second, the time complexity of Pushback is linear in terms of the length of the list, where n is the number of nodes in the list. Because we need to traverse the whole list to get to the last node, this implies that the time complexity is linear. Thank you for watching this video. In the next lesson, we will continue with the other operations. If you liked the video, then please like, subscribe and share, and I'll see you in the next lesson.